2.4, Midsegments and Angle Bisectors, in Unit 2, Segment and Angle Relationships. Take a moment to get a piece of scratch paper. Use a ruler and draw line segment AB on your ruler. Make sure you include endpoints. Fold the piece of paper so that B is right on top of A. This line that you just created, this fold line that goes through your line segment AB, bisects your line segment AB. Let's call it M. So what you've done here is you've demonstrated the concept of a midpoint on a line segment, meaning that AM is now exactly the same length or congruent to MB. You should be able to fold AB again and show that line segment AM is exactly on top of and the same length as line segment MB. That demonstration is called a segment bisector. So you might think of a midpoint, like we talked about in the last lesson, a point that falls in the middle of a line. We can go one step further, and we can take that line segment, bisect it or cut it in half, and we can do that with a point, a ray, a line segment, or even a plane can bisect a segment. You can see in the figure on your right that line CD bisects or cuts line segment AB in half, meaning that AM is congruent to MB. Take a moment and make sure you have this written in your notes. Okay, so let's say we're looking at a skateboard. And we've added geometry on top of the skateboard because everybody does that. Line segment VW goes horizontally or along the short side of the skateboard. Line segment XY goes right through the middle, long ways, down the skateboard. And it says in our prompt here that VW bisects XY. So what it's telling you in the prompt is that VW cuts XY in half. And it cuts it in half at the point T. And then it tells us that the length from X to T is 39.9. And it wants us to find the entire length of XY. Okay, let's get started. If point T is the midpoint of this line segment, that tells us that XT has to be equal to TY. These two have to be the same length. So if XT is 39.9, then TY also has to be 39.9. And if I want to find the entire length XY, I could just use segment addition postulate, which says that XY is equal to XT plus TY. And I know what XT and TY are equal to. We just had that conversation. So that tells me XT is 39.9, TY is 39.9, and when I add them together, I get a length of 79.8 centimeters. All right, now let's throw a little algebra on it. This problem says point M is the midpoint of VW. Find the length of VM. So point M is the midpoint of VW. And it wants me to find the length VM. So just this length. Well, in order to find this length, I need to know what is X. So I can use what we've talked about. Here's my segment bisector, my point M. And I can say, okay, that tells me that VM is equal to MW. and substitute. So that tells me that 4x minus 1 has to be equal to 3x plus 3. And now I just need to solve. Generally, when I'm solving an equation where x is on both sides, I subtract the smaller x first. So you can see here that I've subtracted 3x from 4x, and I'm left with just x. So I have x minus 1 is equal to 3. And now isolating the x, I'm going to add this 1 over and get x is equal to 4. Now this simply solves for x. I do not know the length of VM yet, but I do know that VM is 4 times x minus 1, so all I really need to do is substitute. If VM is 4x minus 1 and x is 4, then I can find VM by doing 4 times 4, which is 16, minus 1, which is 15. I can easily check my work with midpoint problems by simply plugging in right here for MW and making sure that I also get 15. So MW is 3x plus 3, or 3 times 4 plus 3, which is 15. And I've just shown that if VM is 15 and MW is 15, therefore M had to be the midpoint. We have talked about midpoints in the past. We talked about when you're on the coordinate plane, how do you find the midpoint between 2 points? So let's do that again. The endpoints of RS are at 1, -3, and 4, 2. And I want to find the coordinates of the midpoint. So I might begin by graphing my points R and S. Here is R at 1, -3, and here is S at 4, 2. And here's the midpoint. Who knows what it is, but it does look like it's going to be some fraction. Just looking at this picture, I would guess it's at about 2.5 and about -1/2. We can use the midpoint formula by adding the x's and dividing by 2, adding the y's and dividing by 2. So we get x plus 4, which is 5, divided by 2. If I took this to decimals, that would be 2.5. And then -3 plus 2, which is -1, divided by 2 is -0.5. Take your scratch paper from earlier where you found a segment bisector, and now we're going to find an angle bisector. Use a ruler to draw an angle ABC, labeling the points as you see in the picture, A, B, and C. Fold the paper so that BC is right on top of BA. So you're going to fold the paper so that BC is right on top of BA at B. And this figure that you get now has a crease going through the middle of your angle. Put a point along the folded line, anywhere along the folded line, so long as it's in the interior of angle ABC, and label that point D. And then connect B to D, creating a ray that bisects angle ABC. This ray, BD, is called an angle bisector. It's a ray that cuts the angle exactly in half. Take a moment to write down the vocabulary word at the bottom of the screen. Example 3. In the diagram at the right, YW, the ray YW, bisects or cuts in half angle XYZ. And it tells us that the measure of angle XYW is exactly 18 degrees. And it wants us to find the measure of the entire angle XYZ. So the fact that XYW is 18 tells me that WYX has to be the exact same. So if XYW is 18, I did it again, XYW is 18, then WYZ is 18. And really, you can just add those together using angle addition postulate to get an answer of 36 degrees. So I made a little notation here, so you can see this since I fumbled my way through that explanation. If this angle is 18, then this angle has to be 18. So together, all I need to do is add 18 plus 18, and that's what gives me that 36 degrees. Okay, moving on. Example 4. Ray BD bisects angle ABC. The fact that ray BD bisects angle BC tells us that ABD, I might mark these, ABD and DBC have to be the same measure. So what I want to do here is I want to find the measure of ABC, which is this entire outside angle right here. So in order to do that, I need to be able to add these two angles together. But I don't know their measures yet. I only know that ABD is 2x plus 20 and DBC is 4x. But I need to solve for x in order to figure out their actual angle measures. So I'm going to write something I know is true. I know that ABD is equal to BDC. Ooh, this is written poorly. Let's change this. Let's get an orange. I wrote these in the wrong order. This should be D, B, C. There we go. D, B, C. Okay. So that tells me that 2x plus 20 has to be equal to 4x because of this being a bisector. If it cuts it exactly in half, then they have to be equal to each other. Now, again, I have x's on both sides of the equation. So I'm going to subtract the smaller x from each side, which is the 2x. That's going to get rid of x on the left side and leave me with 20 is equal to 2x. Dividing by 2, that tells me that x is equal to 10. Now I need to plug x in to find these individual smaller angles, and they should be equal if I've done the algebra correct. Angle ABD is 2 times x plus 20, or 2 times 10 plus 20, which is 40, when I plug x in. Angle DBC is 4x, which is 4 times 10 when I plug 10 in, and that gives me 40. And this makes me happy right here, the fact that both of these angles equal 40 degrees, because I want them to be the same because of angle bisectors. And I'm just going to put a little degree symbol here and a little degree symbol here because really I should have units going. And then in order to get ABC, I just need to add those together. 40 plus 40 equals 80 degrees. So that tells me that the measure of angle ABC, the thing that I was looking for, is 80 degrees. Okay, you have a quizzes to practice, so go ahead and do that now. And then there is a quiz waiting for you on It's Learning over 2.4. Good luck.